Hi. In the previous video I was talking about a new validation library called Zod, which I had found recently. I considered this library to be a drop-in replacement to my current validation library of choice called YUP. In this video I'm going to share the results of my experiments with Zod, with exact numbers and my final conclusions. Let me start with a brief reminder on why I even consider Zod to replace much more popular YUP. First reason is bugs. Yes, YUP is a buggy library despite its popularity. It has some bugs I absolutely failed to fix. On the application side, some of that bugs belong to its own dependency, Lodash. So these bugs were the initial reason I started to look for another library. Second reason is bundle size and simplicity, and Zod hands down wins in this comparison. It's much easier to use and it's much lighter. The second reason is TypeScript. While I don't necessarily use TypeScript extensively at the moment, I'm still interested in this language and I believe it will grow even more than it is now. So a better TypeScript support is definitely something worth consideration. And probably the next reason are my own preferences. I prefer functional programming and I prefer libraries that are based upon some mathematical background, and this library is one of such examples. Now let's compare these two libraries in terms of their respective popularities. Zod features 1000 a bit more stars on GitHub, while YUP has 10,000, so it's kinda a next level of magnitude. As for NPM downloads, Zod has collected 8,500 weekly downloads, while YUP has an outstanding 1.5 million of weekly downloads. In short, on the axis of popularity, these two libraries are hard to even compare. YUP is a much more popular tool, and if this metric has a higher priority to you or your team, you should probably stick with YUP. Now let's compare build numbers. These numbers were taken from my Next.js build of one of my projects. As you can see from these statistics, some pages which had forms on them got significantly smaller numbers. 267 became 254, for example, or 178 became 165 kilobytes. I believe it's a significant cut. These exact numbers correspond to the production build, minified, tree-shaked, but not gzipped. The next set of data corresponds to the non-tree-shaked set of builds. It is useful to compare non-tree-shaked builds as well, because you don't have tree shaking on your dev stage, and slow dev stages are kinda pain in the ass. Tools are getting bigger and bigger and your dev behavior is getting slower and slower. As you can see here, I replaced YUP with Zod, and YUP is 200 kilobytes, while Zod is, so it's about 2 times smaller. On the third screenshot you can see that the percentage of my own application code for this project got a bit higher, from 33% to 35%. I should probably add that these dev stage numbers affect not only dev performance, but also how long will the project build. Because obviously the more kilobytes are in your codebase, the more time it will take for the compiler to handle, to parse, to compile, to tree-shake, and so on. I didn't save the numbers for the duration of both builds, but trust me, it was a significant reduce. Now let's compare application codes for these two variants of my project. As I mentioned in my previous video, the current version of Zod has some problems with async validation, or I should say not problems but complexities. I was able to overcome those complexities by writing some extra code in my application layer, and this is one of such examples. For example, current implementation of my application code for Zod requires to store the results of async queries in some metadata in my form declarations. It wasn't necessary with YUP, and it won't be necessary with the next major version of Zod, as its creator told me. You will have to take those metadata fields into account while declaring your form widgets as well. And here is probably the most interesting part: two schema declarations. Please don't mind Cyrillic symbols here. It means symbols, basically, literally, from 5 to 50 symbols. It doesn't matter what this tooltip actually is to compare these two declarations. As you can see with YUP, which supports metadata attachment, I was able to define only a single schema object, while with Zod I was required to declare first a schema object, second a metadata object for the tooltips or legends or something, and third the resolution function, which handles those unsupported yet async data stuff. Still, Zod is a bit cleaner and shorter. For example, with YUP there are plenty of required calls. Basically, all of the fields in this case have required attached to them, and with Zod, fields are required by default, which I believe is a better choice. Also, YUP has this shape extra method, while for Zod you don't have to add this shape. Object is more powerful. Other things are more or less equal. And now the conclusion. Am I happy with my experimental migration from YUP to Zod? Yes, absolutely. I was able to implement my whole project with Zod. I reduced my bundle size. I didn't find any bug. There are some shortcomings, of course, but they will be solved in the nearest future, I believe. So if you have some side project, you can implement it with Zod instead of YUP already today. But if you have a production project, it will probably be wiser to wait until the next major release of Zod.